Hello viewers, we are going to look at cube, cuboid, cylinder, cone and spheres, all three-dimensional figures in this class. For every three-dimensional figure, we are going to find out lateral surface area and total surface area and volume of the three-dimensional figure. So, we will start with a cube. Cube is actually a square prism where all the surfaces are same. For a cube, if you look at, there are 6 surfaces, all those surfaces are actually equal. Here, this is upper surface, this is the surface which is bottom. These two are side surfaces and these two are front and back. This is the front surface, this one is a back surface. So, there are totally 6 surfaces. You can imagine, suppose if you are sitting in a room and seeing this video, just imagine that room is a cube, but the condition should be all the surfaces, all the walls including the ceiling and the floor must be in the shape of square, all of them should be equal. So, if all of them are equal, then you can imagine that it is cube, you are sitting in a cube. So, all these surfaces, four walls of your room is nothing but the lateral surface area of that cube. If you include top and bottom surface, then it is nothing but the total surface area of the cube. If you take the volume or else the empty space in the room that you are sitting in, it gives you the volume of that room or else the volume of the cube. For a cube, you have 6 surfaces as shown, and you also have, if in a room you observe, there are 8 corners in a room. These 8 corners are called vertices of a cube. Then you have 12 edges. So, here 4 edges here. You can see 4 edges top, 4 edges bottom, and then after 4 heights, 4 pillars. So, but all edges are equal. Here all of them are equal size A. So, we say for a cube, you will have 6 surfaces. You have 8 vertices, then we have 12 edges. For any polyhedron, just remember, for any polyhedron, surfaces you call it as face, vertices we call it as V, edges we call it as E. The relation between faces, vertices and edges, face plus vertices, number of faces plus number of vertices is equals to number of edges plus 2. This holds good for any polyhedron. You take any polyhedron, this will be true. So, faces plus vertices is equals to edges plus 2. Now, we are going to try to find out what is the lateral surface area, what is the total surface area and the volume of this cube. We know cube is what? Cube is a square prism. So, lateral surface area, here lateral surface area is 4 walls, you can see all 4 of them were squares, all 4 of them are squares, therefore 4a square. You can say base perimeter of a square is 4a into height. In this way also you will get it. Total surface area is all 6 squares, therefore 6 into a square. When it comes to volume, length into breadth into height, a into a, or else you can say base area into height. Base area is a square, height is a, therefore volume of a cube is a cube. So, lateral surface area is 4a square, total surface area 6 squares, therefore 6a square, volume of a cube is a cube. Now, look at the diagonal of the cube. See, you call it as a diagonal of a surface if you draw diagonal on the surface, but if you draw this imaginary line, this is called the diagonal of the cube. How do I find it out? See, diagonal of the surface, when it comes to diagonal of the surface is a square, therefore it is square diagonal root 2a. This is diagonal of surface. Because surface is a square, therefore diagonal of a square is root 2a when it comes to surface. But diagonal of cube is equals to, this is a root 2a, Pythagoras rule, because it is 90 degrees. So, if you take a and root 2a as 2 sides of a right angle triangle, hypotenuse becomes the imaginary line and the largest possible length inside a cube, that is under root of a square plus root 2a whole square, which is 2a square. Put together it becomes under root of 3a square, which is root 3 times of a. It is a diagonal of the cube. It is not only diagonal of the cube, this is the largest length which is possible inside a cube. If you want to put a rod of length something, they will ask you what is that length of the rod which you can put it on the cube of side A. So, length of a rod which can be inserted in the cube of side A is equals to root 3 times of A. So, these are the very important formulas related to cube. Now, let us look at the 3-dimensional figure of a cube. Just look at the 3-dimensional figure of the cube. See how a cube looks like in a 3D. So, you can imagine here all surfaces are square surfaces. Here also all of them are simply square surfaces. If suppose if you drag this a bit further, then we get a cuboid. So, here length, breadth, height changes, therefore, you call it as a cuboid. Length, breadth, height may be equal or may changes. These kind of figure you call it as a cuboid. Now, let us first figure it out in the 2-dimensional thing. Now, this one is a cuboid. Length, 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 4 edges here, 4 breadths and 4 heights. Heights is nothing but you can assume that the pillars of the room. What is the lateral surface area? See here. Lateral surface area means area of 4 walls. This is LB, HB, HB. So, there are 2 HBs and front and back. This is LB, HL, this is HL. So, there are 2 HLs and 2 HBs. And what is the top and bottom? The top one is LB and the bottom one is also LB. So, if you look at the lateral surface area, there are 2 HBs, there are 2 HLs. If you common 2H, which is L plus B, or else you can call it as a rectangular prism. What is a prism? For a prism, what is the lateral surface area? Base perimeter, that is 2 into L plus B rectangle into height. It is same. Now, when it is a total surface area, you need to add 2 rectangle areas. So, here 2 rectangle areas are what? So, LB and LB. So, we can say it is 2 times of 2 LBs are there, 2 BHs are there, 2 HLs are there. So, this is a total surface area of the cuboid. When it comes to volume, it is simply length into breadth into height. So, volume of the cuboid is base area into height also you can say, where base area is what? Base area is a rectangular area, that is L into B, height is H, therefore, LBH is the volume of the cuboid. Now, look at for a cuboid you have diagonal of the surface and also the diagonal of the cube. The red color one is the diagonal of the surface, blue color one is the diagonal of the cube. Diagonal of the surface depends on which rectangle you are taking. Here I am taking the rectangle which is on the ground or the base, that is L and B are the sides, therefore, the length of the diagonal is equals to under root of L square plus B square here. If you apply Pythagoras rule to H and this diagonal, then you will get the greatest or the largest possible distance inside a cuboid, that is the diagonal of the cuboid is equals to under root of L square plus B square plus H square. So, this is the largest possible distance inside a cuboid. It is diagonal of cuboid, right. Now, we look at how a cylinder looks like. Cylinder is a circular prism. Cylinder is a circular prism. So, you can apply the formulas of the prism to this cylinder. Lateral surface area, if you connect these 2 centers, distance between 2 centers is height, center to anywhere on the circle is radius. So, only you have two values to it, radius and height. Lateral surface area is base perimeter, base is a circle, therefore 2 pi r is the perimeter of the circle or circumference of the circle into h. So, therefore, lateral surface area is 2 pi r h. When it comes to total surface area along with the lateral surface area is 2 pi r h. You need to add two circles is 2 pi r square. If you common 2 pi r, you will get h plus r. This is the total surface area of the cylinder. When it comes to volume, we know for a prism, volume is base area, that is pi r square into h. So, this is the volume of cylinder. Look at the three-dimensional figure of a cylinder. This is how a cylinder looks like in a three-dimensional figure. So, here top surface is a circle and this one is also a circle. So, this is a cylinder. You call it as a right circular cylinder. It is not tilted. This is tilted cylinder. This one is a right circular cylinder. That is the reason whenever you see right circular cylinder, which means the height of the cylinder is perpendicular to the base, or else the base is parallel to the base. So, remember, this is not a right circular cylinder. Okay, this is not a right circular cylinder here. What is right circular cylinder? Right circular cylinder means perfectly 90 degrees it is, like this. Next, look at cone. Cone is nothing but a pyramid. It is a circular pyramid. Here base is a circle. You attach it to a apex point. Actually, all vertices of a polygon which you are taking on the base should be added to the point, so that you will form a pyramid. Here it is a circular pyramid, you call it as a cone. For this you will be having height of the cone, radius of the cone and slant height of the cone. So, this is height, radius and the slant height. The relation between height, radius and the slant height is h square plus r square is equals to L square, where L is the slant height. Lateral surface area of a cone or else a pyramid is half into base perimeter, means circumference of a circle 2 pi r, into slant height which is L. Pi r L gives you lateral surface area of a cone. What is the total surface area of a cone? Total surface area of a cone is, to lateral surface you add one base area is pi r square. Therefore, common pi r, you will get L plus r. Now, what is the volume? Volume of a cone with the same dimension is simply 1/3 of the prism volume. Prism means here cylinder. So, 1/3 of the volume of the cylinder. If the dimensions are same, 3 cones is equals to 1 cylinder in terms of volume. 1 by 3 pi r square h is the volume of the cone. Have a look at the three-dimensional figure of the cone. So, this is how a cone looks in a 3D. See here, this is the apex. Now, here is the base. Base area is what? Pi r square. All this side area, it is actually, you are looking at a triangle, but it is not exactly a triangle. It is actually a shape of a sector of a circle. That area is pi r L, where L is the slant height. Now, we will look at a sphere. Sphere is nothing but a ball shaped figure. I am drawing a circle here, but in fact it is not a circle. It is like a ball shape. If you can imagine a 3D figure, just imagine like this. You can imagine a cricket ball or a football or a volleyball. So, this is nothing but a sphere. Now, sphere, in order to find out the formulas for sphere, like the lateral surface area and total surface area and volume, for a sphere you can say there is no lateral surface area. It is everything about lateral surface area is nothing but total surface area only, because there are no up and down surfaces. A ball does not have up and down surfaces. The lateral surface area is same as total surface area. Simply we say surface area of the sphere. Now, in order to find out, just imagine the sphere is, it's a confluence of 4 cones. Imagine sphere is formed by using 4 cones. In order to get the formula, you just remember it like this: cone 1, cone 2, cone 3, cone 4. So, it is formed by using 4 cones. Therefore, the entire surface of the sphere is covered by using 4 circles. This is one circle, circle 2, circle 3, circle 4. Therefore, remember these are all radius. Total surface area or else the surface area of a sphere is formed by 4 circles with the same radius as the radius of the sphere. So, it is 4 pi r square. When it comes to volume also, 4 into volume of a cone is 1/3 of pi r square h. Here h is also same as r, therefore multiply it with r. So, remember that a sphere is formed by 4 cones in order to remember the formulas. So, what is the volume of the sphere? It is 4 by 3 pi r cube. So, this is the volume of the sphere. When you take a hemisphere, just imagine a watermelon, a complete watermelon. When you cut a watermelon into 2 parts, see how it looks like. It is a 2-dimensional figure, but you can imagine this is a green surface of the watermelon, this one is the red surface of the watermelon. So, this green surface is actually half of the surface of the complete cube. So, this green surface having the area of 2 pi r square, you call it as a lateral surface of hemisphere. This is the lateral surface area of hemisphere. When it comes to total surface area of the hemisphere, then it is another pi r square is added because this extra red surface is added, that is also in shape of circle, therefore it is 3 pi r square. When it comes to volume, you are dividing the sphere into 2 equal parts, therefore volume of the sphere, volume of a hemisphere becomes half of the volume of the sphere, which is 2 by 3 into pi r cube. This is the volume of hemisphere. So, here in the exam they may ask you, they may melt 10 hemispheres, they can form one full sphere. Then everything changes, lateral surface area, total surface area, then after radius, everything will change when you convert, when you melt one figure into another, okay, to form another figure. Remember, one thing remains the same, that is volume. So, when one figure is converted to other by melting or by any other process, all you have to do is simply equate both the figures' volumes. Suppose you are melting 100 spheres, you are forming one big cone. So, equate the volume of the 100 spheres, equate it to the volume of the big cone. Okay, by equating it, you will get the unknown values. Now, look at the hemisphere in 3-dimensional figure. See how it looks. Now, this is a hemisphere. This one is the surface, it is 2 pi r square. Now, this is actually the red one. It is a circle which is pi r square. Now, this is 2 pi r square and the volume is exactly half of the sphere. Now, we also find out what is the hollow cylinder. So, this is actually the hollow cylinder. Hollow cylinder means empty inside like this, which will have certain thickness. Now, you can see this cylinder has a thickness. It has a inner radius and outer radius. All you have to see, how do we find out for this? So, hollow cylinder, how do I find out the lateral surface area? The lateral surface area of the hollow cylinder, you can just add the inner sphere lateral surface area, that is 2 pi r h. The outer one is radius, you take it as capital R, 2 pi capital R into h. H is same in both the cases, therefore 2 pi small r plus capital R into h is the lateral surface area. When it comes to total surface area, you add lateral surface area. There are 2 rings. Area of a ring is pi capital R square into small r minus small r square. So, therefore, there are 2 rings, one is upper ring and the one is the ring which is below. So, 2 into pi into capital R square minus small r square. It comes to volume, outer cylinder, pi capital R square minus small r square into h. I am just subtracting the volume of the inner cylinder from the volume of the outer cylinder in order to get the volume of the hollow cylinder. What is very important in cylinder is also hollow cylinder. In hollow figures, remember hollow cylinder values. Another hollow figure which is very important is hollow hemisphere. It is like a ball with certain thickness. It's like a ball with certain thickness. You can imagine a ball with certain thickness here. So here it is a ball, hemispherical ball with certain thickness. This thickness in case of hollow cylinder and hollow hemisphere is capital R minus small r. You will get this thickness by subtracting small r from capital R. What is very important in this? Lateral surface area. It is 2 pi capital R square plus small r square. Both the lateral surface areas you add it. Total surface area. Along with the lateral surface area, you will have one ring, that is pi capital R square minus small r square. When it comes to volume, 2 by 3 pi, from the outer hemisphere you subtract the inner hemisphere volume. So 2 by 3 pi capital R cube minus small r cube. So you will get the hollow hemisphere volume. Now look at what happens when a cone, I am taking the front view of the cone. When you are cutting a cone by using a plane which is parallel to the base, you are cutting the cone into 3 parts by using a plane which is parallel to the base. You are cutting the height of the cone into 3 equal parts. So I am cutting it into 3 equal parts. And if you can see this smaller triangle and the second smaller and the larger, all the 3 triangles here, triangle 1, this is triangle 1, this is triangle 2, this is triangle 3. All these triangles are similar to each other, and if you look at their heights ratio, this is 1, front view of it I am just talking about, 1, 1, 1. When you look at these triangles, it is 1. When you look at this particular triangle, it is 2. When you look at this particular triangle, 3. That sides ratio is 1:2, 2:3. It appears like 1, 1, 1, but it is 1:2, 2:3. When sides ratio is 1:2, 2:3, just imagine how a cone looks like after cutting it. This is how the 3 parts of the cone looks like. Now what is the ratio of volume 1, volume 2, volume 3? I know volume 1 is 2, volume 1 plus volume 2 is 2, volume 1 plus volume 2 plus volume 3, which means first cone, second cone, third cone. We know sides, right? Sides are in the ratio 1:2:3, therefore volumes in the ratio 1 cube is to 2 cube is to 3 cube, which is 1:8:27. If V1 is 1, then what is V2? Then what is V3? If V1 is 1, V2 is 7, then V3 is, out of this 28 you subtract 8, it will be 19. If you add V1 is a perfect cube, V1 plus V2 is also a cone, so it is also, the volume is a perfect cube. Now V1 plus V2 plus V3 is also a cone, it is 1 plus 7 plus 19, it is 27. So you can just, by looking at the values, you can get it from the options. V1 is a cone, V1 plus V2 is a cone, V1 plus V2 plus V3 is also a cone. Their volumes will be in the ratio 1:8:27 when you take one cone and second cone and the third cone. But V1, V2, V3 individually, if you look at, their volumes are in the ratio 1:7:19. Now volume of a cylinder, for a cylinder I am telling you, volume of a cylinder is pi r square h. Here the variables are r and h, therefore volume is directly varies with r square h. If I take volume of a cone, volume of a sphere, volume is 4 by 3 pi r cube. So volume is directly varies with cube of radius. Here radius square and height, here cube of radius. Remember, if height is same, if height is a constant, then volume varies with the square of radius. Here there is no height, therefore it depends completely on what? Radius. For only sphere, surface area varies with square of radius. When it comes to volume, it varies with the cube of radius. If radius is increased by x%, then surface area, increase in the surface area, I am directly giving it as a formula. We know it in percentages. I think we have seen it in percentages. It is x followed by x percentage increase means 2x plus x square by 100. This is when x percent increase. When x percent decrease, 2x minus x square by 100. When it is volume, then you can say 3x plus 3x square by 100. Remember it as a formula, plus 3 plus x cube by 10,000. You can take same thing here, but here you can take, instead of plus plus plus, you take plus, then after minus, then after plus, right. So, x percent decrease followed by x percent decrease followed by x percent decrease is 3x minus 3x square by 100 plus x cube by 10,000 decrease. The lateral surface area is 2 pi r h. The variables are r and h. So, r is increased by x percent, h is increased by y percent, then the increase or decrease. Therefore, what happens to area? Plus r minus x plus r minus y, you can say plus r minus x y by 100. Like this you have to take the variables. In this chapter, we have seen cube, cuboid, cylinder, cone and a sphere. Along with them we have also seen the hemisphere and hollow cylinder, hollow hemisphere. So, for all these figures we found lateral surface area, total surface area and volume, and we have also seen how surface area and volume depends on radius and height and various things. Thank you.